Alright, so for some reason my recording got messed up there. So here's where we left off. Number 11, I was saying that I have 6 radical 10 because it was 36 times 10. So that would turn into 3 radical 10 because half is 6 and unit squared. Alright, so for number 12. Number 12, you are given the endpoints of a sphere, the diameter of a sphere. So I have to find the midpoint of those 2 points to find the center of the sphere. So I have to add these points and divide by 2. So 4 and 0 adds up to 4, divide by 2. Negative 2 and 8 makes negative 10, divide by 2. 1 and 5 makes 6, divide by 2. So there's my center. So I now know I can do x minus 2 squared, y plus 5 squared, z minus 3 squared, but this is my center. I need to use my center and one of those endpoints. I'll just use 4, negative 2, 1, because the distance between the center and that endpoint of the diameter is going to be the radius, and I need that squared over here. So that distance right there, I have to do the square root. I've got to subtract these. 4 minus 2 is 2, so I'll square that. Negative 2 minus negative 5 is 3. 3 squared is 9. And 1 minus 3 is negative 2, but negative 2 squared is 4. So I get the square root of 17, but remember I want my radius squared, so I'll just put 17 right here. Alright, number 13. 13 asks for OL and OR. Well, if you're going from the origin, which is what O is, to point L, then your vector would be negative 3, 2, 5. And OR would be 1, negative 6, and 4, because you're subtracting 0 from these. So the next part of the question says find the cross product. So I have to do this, set up my determinant. Okay, so my first spot, cross off I get 8 minus negative 30, so 38. Then I get negative 12 minus 5, so negative 17, but I'm going to change that to a positive. And then here I get I get 18 minus 2, so I get 18 minus 2, so 16. Let me make sure that's right. Yeah. Okay, sorry. And I want them, this is my cross product. Part C says calculate the area of a parallelogram that has these 2 vectors as its sides. Well, that means it's just the magnitude of the cross product of OL and OR. Well, I already have that here. So the magnitude would be the square root. Let's square those and add them up. So I got 38 squared plus 17 squared plus 16 squared. And that comes out to 1989 inside here. And it's an area, so we will say units squared. Alright, number 14. So given these 2 vectors with lambda, so that variable right there. So, let's see. I got 2 lambda plus 3, 4. Lambda minus 2, lambda, and 2 lambda. Find all values of lambda for which A is perpendicular to B. So remember that perpendicular vectors, their dot product is equal to 0. So this is something I can calculate. So 2 times that one, so 2 times lambda minus 2, plus lambda plus 3 times lambda, plus negative 4 times 2 lambda, so that'd be negative 8 lambda. This equals 0. So I hope you see here I have a quadratic. So I have 2 lambda minus 4 plus lambda squared plus 3 lambda minus 8 lambda. You can change them to x's if you want. So I got lambda squared. 3 minus, let's see, 3 plus 2 is 5. 5 minus 8 is negative 3. And so then I have plus, oops, so this is gone, that's gone, that's gone. All right, so minus 4. All right, you factor that up. So I get minus 4 and plus 1 to make that happen. So lambda has to be 4 or negative 1. So I get two solutions. All right, number 15, find the projection. So I want the projection of u onto v. So that is going to be a multiple of v. It is the dot product over the magnitude of v squared. All right, so v, it tells me, is negative 2, 4. U is 5, negative 1. All right, so their dot product will be negative 10 plus negative 4. So negative 14. Magnitude of v will be radical 4 plus 16, so radical 20, so it'll be a 20 down there squared. Radical 20 squared is 20. All right, so this changes into 7/10. So I have a negative 7/10 times negative 2 and 4. Okay, so I have, when I multiply this out, I get negative 14 over 10. So 14 over 10 will be 7 over 5. And then I get negative 28 over 10, which will be 14 over 5. Okay, so last part of that says write u as a sum of two orthogonal vectors, one of which is the projection vector. So u, that would be 5, negative 1, is the sum, so the addition of this vector here and some other vector, and they're going to be orthogonal. They're definitely going to be that way anyway. So basically all I have to do, if I do 5 minus negative 7/5, I'm going to get this piece right here. So I'm going to cheat off my answer. That 5 minus negative 7/5 would be 18/5. And negative 1 minus negative 14/5 would come out to 9/5. So that is that setup. So u is the addition of these two. If you dot these two, they will be 0 because they are perpendicular. All right, 16, what is the geometric meaning of cross product? So when you do the cross product, it gives you a third vector that is in fact perpendicular to both of the original vectors that you used to calculate the cross product. So that's what you need to know from that. And finally, number 17. All right, an airplane needs to go 500 miles an hour west. So it needs to go 500 miles an hour west. That's what you want it to happen. So 500 that way. So I'm going to make up a vector for what it wants to do. This vector is 180 degrees, so we have cosine of 180 and sine of 180, and it's 500 here. So cosine of 180 is negative 1, sine is 0. So it wants to go left 500, right? So negative 500, comma 0. That's left 500 miles an hour. Okay. Oh, let's see, a wind is pushing the airplane off course. The vector of the wind is 65 cosine 20, and 65 sine 20. So what that means is that the wind is pushing us, the wind is going like this, 65 miles an hour, 20 degrees right here. So that's the wind, okay? So, in what direction and with what speed must the pilot fly the plane so that the result is what we need it to be? So this is the wind. So what the plane is trying to do plus the wind equals, has to equal what we want to do. Okay. So the plane has, what the plane actually does, what he's trying to do, plus the wind has to equal what we want to happen. Well, this is what we want to happen. This is the wind. So I need to know what should I try to do so that these two things happen. All right, so basically we need to take this vector and subtract that one, right? So I need so what should I try to do to make, with the wind, what I want to do happen? So I take negative 500. I'm going to subtract this over here. So negative 500 minus my 65 cosine 20. All right, so negative 561.1. Then I have to take 0 and minus that, as minus the 65 sine 20. So 0 minus sine 20. So negative 22.2. All right. So what's happening here, this vector is negative. So I'm going to have to fly. So see if you can get this straight. I'm going to have to fly this way, because when the wind right here pushes me that way, I'll end up getting to do exactly what I want to do originally, right? What I wanted to do to begin with. Okay? So we want the information about this. So I should fly at what angle and what speed? So the speed is going to be the square root of 561.1 squared plus 22.2 squared. I should fly at 561.5 miles per hour. And the angle right here is third quadrant, so we'll do second tangent, and 22.2 divided by 561.1, and they're both negative, so positive. So this degree right here is 2.3, let's say. All right, 2.3 degrees. So we could say just like a true bearing of over this way. I think I'll use this angle right here and say south is there. So I will say some degrees west of south. So let me move that over. So let me figure that out. So I need 90 minus the last answer. So 87.7. So 87.7 degrees west of south. I should fly at 560 miles an hour, 61 miles an hour, and then I will get where I want to go. Okay, that is it. Because it's like you're overcorrecting for the wind, right? All right, that's it. Sorry I had to break these up in 2 videos. My computer fouled up, but that's it. Bye-bye.